We have a confidence interval problem for two populations. Sigma is known. We've got the data for this in the table right here. And we've got some information about, okay, so we've just got two populations, no more information about it than that. We want a 95% confidence interval estimate for the difference between the two populations. Okay, so it's just a simple calculation here that we'll do. We are going to calculate the point estimate, identify the critical value, and then develop the confidence interval using this equation right here. So the point estimate is x bar 1 minus x bar 2, so we have 42.3 minus 32.4 equals 9.9. So that's our that's our point estimate. So that's going to go in the middle here of our confidence interval, 9.9, and it's going to be 9.9 plus or minus our critical value z, since sigma is known, and then we will calculate that out. So our for a 95% confidence interval estimate, right, if you might just remember that it's 1.96. If you don't, you can divide the 95% by 2 and we find 47.5, and then you can see then in looking at the table it's 1.96. Okay, and then we would multiply that by the square root of 3 squared over 50 plus 2 squared over also 50. Okay, and then we end up with plus or minus, well, 0.999, and we'll say that's about 1. Okay, and so then we end up with a confidence interval of 10.9 to 8.9. Okay, again, I'm just sort of ballparking this plus or minus 1 there. You could do it exactly if you wanted, and on the test it would show you whether you needed to do that or not. But for our purposes here, I think that demonstrates what it is we need to do.